The world of artificial intelligence is no longer a futuristic concept. It is here, it is changing every job, every industry, and every facet of modern life. Yet, for many, it remains a black box. Today, we are changing that. Welcome to LearnFlow. I'm your host, and over the next half hour, we are embarking on a complete, foundational journey to demystify modern AI. This isn't just an overview. It's a detailed, step-by-step roadmap designed to take you from zero knowledge to a confident understanding of the fundamental concepts powering this revolution. By the end of this deep dive on LearnFlow, you will have a clear structure, key terminology, and an actual actionable plan to begin your AI learning journey. I've broken this down into 4 critical phases, and I highly recommend you stick around for phase 3, where I reveal the essential free software toolkit and the simple coding language you need to start building AI today. Let's dive in and unlock the future together. Phase 1. Defining the AI ecosystem. To understand the forest, we first need to identify the trees. The term AI is often used loosely, so let's establish the correct hierarchy. Think of it as a set of nested Russian dolls. The biggest doll is artificial intelligence. This is the general goal, building machines that can simulate human intelligence. This includes everything from simple logic puzzles to complex decision-making. The second doll inside AI is machine learning, or ML. This is where the magic happens today. Machine learning is a method of achieving AI by giving a system the ability to automatically learn from data without being explicitly programmed for every single task. Instead of writing code that says, if X, do Y, we give the machine enough data for it to figure out the rule itself. The smallest, most powerful doll is deep learning, or DL. Deep learning is simply a subset of machine learning. It uses a specific, complex architecture called artificial neural networks, structures inspired by the human brain, to process data. While ML can handle simple tasks, deep learning is what powers complex recognition like facial identity, sophisticated translation, and the large language models you use every day. Here's the simplest way to remember it, a core takeaway from LearnFlow. Deep learning is a type of machine learning, and machine learning is a way to achieve artificial intelligence. Now, let's zoom in on the deep learning engine, the neural network. A neural network is made up of layers of interconnected nodes, or neurons. Data enters the input layer where it is processed. It then moves through one or more hidden layers, which is where the system performs complex calculations or feature extraction to learn patterns. Finally, the processed information exits through the output layer, giving you the result or prediction. The deep in deep learning simply refers to having many hidden layers, allowing the network to learn increasingly intricate and abstract patterns. This structure is what gives modern AI its immense power. Phase 2. The 3 pillars of learning. Every machine learning algorithm you will ever encounter fits into one of 3 fundamental categories based on how it learns. These are the 3 pillars of data science, and understanding them is essential for any aspiring builder on LearnFlow. 1. Supervised learning. This is the most common type. The key here is labeled data. Think of it like learning with a teacher. The data you feed the model is carefully labeled with the correct answer. The model makes a prediction, compares it to the correct label, and adjusts its internal structure to reduce the error. This is a continuous process of teaching and correcting. Supervised learning solves 2 primary problems. Classification, which is predicting a category, for example, classifying an email as spam or not spam, and regression, which is predicting a numerical value, for example, predicting the exact sale price of a house. 2. Unsupervised learning. This is learning without a teacher. The data is unlabeled. The algorithm is simply given the raw data and told to find hidden structure, patterns, or groupings within it. The most common application is clustering. Imagine an online retailer. They don't label their customers. An unsupervised algorithm can group all customers into distinct segments. For instance, high-value frequent shoppers and occasional discount buyers. The algorithm discovers the groups based on behavior, allowing the business to then target those specific clusters. Another use is dimensionality reduction, which simplifies complex data by reducing the number of features while retaining the most important information. 3. Reinforcement learning, RL. Reinforcement learning is dynamic and futuristic. It's learning through trial and error in an environment. The system, called the agent, performs an action within an environment. It then receives a reward for desirable behavior or a penalty for undesirable behavior. The goal of the agent is to learn a series of actions, a policy, that maximizes its total reward over time. This is the mechanism used to teach systems how to play and master complex video games, control robotic arms in manufacturing, or optimize traffic flow in a simulated city. This paradigm allows AI to learn complex, long-term strategies that were previously impossible to hardcode. Phase 3, the LearnFlow Practical Toolkit. Theory is great, but here on LearnFlow, we are all about action. Artificial intelligence is changing the world in ways that are both obvious and subtle. If you look around, it's everywhere, in your phone, your computer, the apps you use, and even in some of the services you take for granted. But despite its ubiquity, many people feel like AI is something far away, like a futuristic concept in movies. The truth is, AI is here, it's real, and it's quietly shaping almost every aspect of our daily lives. To understand why AI feels so powerful today, it helps to go back and look at how it started. The concept of AI has existed for decades, long before modern computers could even process basic instructions. Early thinkers imagined machines that could reason, solve problems, and even think in ways similar to humans. In the 1950s, computer scientists began experimenting with programs that could solve puzzles, play games like chess, and even prove simple mathematical theorems. These early AI systems were rigid and rule-based. They didn't learn from experience. They couldn't adapt. But they were the first sparks that would eventually ignite a revolution. Fast forward to the 1980s and 1990s, and we see the rise of neural networks, a type of AI inspired by the human brain. These networks were small and limited at first, able to recognize simple patterns such as handwritten numbers. But as computers became faster and datasets larger, neural networks could start to learn from millions of examples. This was a huge leap. Suddenly, computers weren't just following strict rules, they were learning patterns and making predictions. This paved the way for speech recognition, image recognition, and early forms of machine translation. By the 2010s, deep learning had taken the stage. Deep learning is essentially a neural network with many layers, allowing AI to understand context and meaning. Instead of recognizing just a word or a shape, AI could start to understand the relationships between them. This enabled voice assistants like Siri and Alexa, real-time translation apps, and recommendation systems that could suggest movies, music, or products with uncanny accuracy. And now, in the early 2020s, we are entering a completely new era: multimodal AI. Multimodal AI can process and combine text, images, audio, and sometimes video at the same time. Imagine taking a photo of a complicated diagram in your textbook and asking an AI to explain it step by step. Or uploading a video clip and asking it to summarize the key points in minutes instead of hours. This ability to combine multiple forms of input allows AI to function more like humans, seeing, listening, reading, and understanding all at once. But AI isn't just learning to understand. It's learning to act. That's where AI agents come in. These are systems that can perform tasks independently, following multi-step instructions. For example, you could ask an AI agent to plan your week, organize your files, summarize research, and even write a draft report. Over time, AI agents will handle more and more complex tasks, acting almost like digital teammates. They won't replace humans, but they will help us focus on higher-level thinking, creativity, and decision-making. Big tech companies are leading the charge. Google is transforming search, turning it into a conversational assistant. Instead of scrolling through pages of links, you can ask a question and get a clear, organized answer that pulls from multiple sources. Gmail can draft emails, summarize long threads, and highlight urgent messages. Google Docs can take messy notes and rewrite them into polished, professional documents. And Google Photos can organize your memories automatically, recognizing faces, objects, and events with ease. Microsoft is integrating AI into Windows and Office, but in a slightly different way. Instead of just answering questions, Microsoft wants your computer to anticipate your needs. You might ask your computer to compare several spreadsheets, organize your files, or summarize a long report. The goal is to make computers feel like intelligent partners, not just tools that sit on your desk waiting for instructions. Apple is focusing on privacy and personalization. Their AI works locally on your device, meaning sensitive data doesn't have to leave your phone or laptop. Apple's AI improves autocorrect, voice commands, photo recognition, and accessibility tools. Over time, your iPhone or Mac will feel like a personal assistant that understands your habits, preferences, and routines, all without compromising privacy. Open source AI is changing the landscape as well. Developers and hobbyists can now access powerful models and build custom tools. Students, small businesses, and creators can create AI apps for very specific purposes, from composing music to analyzing legal documents to designing 3D models. This democratization ensures that innovation comes from everyone, not just the largest corporations. AI is transforming education in ways that are already noticeable. Students can access personalized tutoring that adapts to their learning style. If a student struggles with a math problem, AI can break it down with visuals, examples, and step-by-step guidance. Teachers can use AI to design lessons, grade assignments, and monitor student progress. The result is a learning experience that can be tailored to every individual, something impossible in a traditional classroom with 30 or 40 students. In the workplace, AI automates repetitive tasks like scheduling, writing reports, or analyzing data. Employees who use AI become more productive and can focus on higher-value work, like strategy, creativity, or problem-solving. Marketing teams can generate content ideas faster, finance teams can analyze trends instantly, and customer service teams can use AI to respond to inquiries with speed and accuracy. AI doesn't replace workers, it enhances their abilities. Creativity is another area where AI is expanding opportunities. Musicians can explore new harmonies, writers can brainstorm ideas or refine drafts, game designers can build complex worlds and characters, and filmmakers can visualize scenes before even picking up a camera. Even people who have never trained in art, music, or design can now create high-quality work. AI acts as a collaborator, amplifying human imagination. In healthcare, AI can analyze massive amounts of data, from MRI scans to genetic information, helping doctors detect issues earlier. Hospitals can optimize staffing, track outcomes, and improve patient care. In science, AI accelerates research, helping analyze climate data, discover new materials, simulate experiments, and study astronomical images. Tasks that once took years can now be done in weeks or months. Transportation is evolving too. While fully self-driving cars are still in development, driver assistance systems like automatic braking, lane keeping, and adaptive cruise control are already improving safety. Public transit systems can predict passenger demand and adjust schedules. Traffic flow can be optimized, reducing congestion. Over time, AI will make transportation safer, faster, and more efficient. Language barriers are also breaking down. AI translation is improving to the point where conversations between people who speak different languages may become effortless. Real-time translation glasses could display subtitles instantly. Video calls may automatically translate speech. This has the potential to revolutionize global communication, education, and collaboration. Looking to the future, AI will become more proactive and personal. Devices will anticipate needs, suggest helpful actions, and automate mundane tasks. Homes may adjust lighting and temperature automatically. Your car may monitor conditions and provide safety alerts. Work tools may automatically organize tasks and summarize progress. AI will act almost like a digital partner, enhancing productivity and quality of life. In creativity, AI will allow anyone to create professional-level content with minimal experience. Art, music, writing, filmmaking, and game development will become more accessible. People will spend less time struggling with technical details and more time focusing on vision and creativity. Workplaces will continue evolving. AI will handle repetitive tasks, freeing humans to make strategic, emotional, and creative decisions. Careers will emerge in AI management, workflow design, testing, and implementation. People who learn to collaborate with AI will thrive. Healthcare, education, transportation, entertainment, and social connection will all benefit. Personalized learning will help students everywhere. Personalized medicine may predict illnesses before symptoms appear. Personalized entertainment will adapt to each person. Personalized communication will allow seamless global collaboration. Challenges exist. AI-generated content can mislead or misinform. Bias must be addressed. Privacy must be protected. Ethical guidelines will be essential. But these challenges can be managed with thoughtful design and regulation. AI will not become conscious or alive. It will not have goals, desires, or emotions. Its power depends entirely on human guidance. Looking 20 to 50 years into the future, AI will be deeply embedded in society. Cities, homes, workplaces, schools, hospitals, and transportation systems will integrate AI to improve efficiency, safety, and accessibility. Robots may assist in disaster response, healthcare, manufacturing, and space exploration. Creativity and problem-solving will continue to flourish, supported by AI tools that make high-quality work more achievable than ever before. Daily life will be transformed. Devices will anticipate needs. Systems will adapt automatically. Global collaboration will become faster, easier, and more inclusive. AI will enhance human capabilities rather than replace them. By understanding AI today, we prepare ourselves for a future that is not just smarter, but more capable, more creative, and more connected than ever before.